Boom. It's going? Okay, we're going. Here we go. Alright, so section 3.3, continuing with this probability idea. So we have basically some rules that we've been talking about, and I've been trying to show you as we go. One big rule is called the multiplication rule. So the multiplication rule basically states this. So what do I want to say here? So we have this multiplication rule, which can also be written as P of A and B is equal to, notice the B and the B here. Maybe if I wanted P of A here, I could write it as P of, so how would I rewrite this, I guess, if I have P of A instead? I need some help. I'm tired today. P of B given A, exactly. Exactly what that would be. So P of B given A. So trying to point out, right, what's the similarities, right? I'm given B in this case, and I'm multiplying by the probability of B. Here I'm given A, I'm multiplying by the given A scenario. So these are for non-independent events. So it's a multiplication rule for this. So we can go over some examples with cards. Maybe I'll bring up some cards, a deck of cards in a second, so we can talk about it and go from there. So, all right. So the probability of A given B equals the probability of A and B divided by the probability of B. So those are just words giving us the same statement we have. But one thing we need to point out here is, I don't know how hard we need to point this out, because even if we use this rule, whether it's independent events or dependent events, it still works. So that rule is true no matter what. And we can expand it up to multiple times. It doesn't just have to be two probabilities, so kind of thing. It's not this event and this event. It could be this event and this event and this event and this event. So think poker or something like that, if you know poker, right? 5-card poker, you have 5 cards, and getting those probabilities, right, of those exact cards you want is really challenging, kind of thing. So it takes 5 and statements. I want 5 events to happen for me to get that royal flush or whatever we're talking about in terms of poker. So right, if you don't know poker, no big deal. It still takes 5 cards, and it's an and statement to happen with those 5 cards, and it's dependent event kind of thing. So when we're talking about dependent events, we have this given condition that we can rewrite. So if I have the probability of A and B and C, maybe I should just write it on this thing. So we could expand this to multiple events. Oops, eraser, look at that. So probability of A and B and C, right? I can do multiple ones. Would be equal to the probability of A times the probability of B given A times the probability of B. Times the probability of B given A, C given A. Dang it. I gotta wake up at some point today. Of C given A and B. So, and it just keeps going. I don't know. We could literally keep this going. There's no necessarily stopping it. So this expands. This multiplication rule expands. Yes, it's infinite. So it's infinite in that sense that it can keep going, but we don't do it that far. So, all right. So with that in mind too, we can have events that are independent, and when we have events that are independent, it just makes it a little easier for us. So when I have independent events, we've talked about this rule. So this is something I want you to start incorporating into your head, that these two things, that this essentially is the definition of, so if I say something's independent, you're thinking immediately of this little formula right here. So that it doesn't matter whether I'm given B already happened or not, it's still the same probability, is what this tells us. It was just an added event that I added on, right? So I can add on multiple events is what I'm talking about, and incorporate even further what we're doing. Bree and then Sarah.
3.2, it has all the formulas for when you think of independent events.
Yeah. And it's really just this main one to me. So one way or another, if we think of this in general, this little independent event, we can relate to independence, and it helps us think about it. If we have independence, then this little phrase that we just made, this little statement we just made here, becomes a little bit easier without the given condition. So, and we can talk about both probabilities, and we will. So, and you have some on your homework. So we have formula, right? Let's do an example. Let's do an example of this. So let me see. We don't know cards. So have I brought out the deck of cards before?
Yeah.
In here? Yeah. Let me just do it again because I'm already going. So let me bring up a deck of cards. So that way we have it in front of us. Probably not going to ask this on the test because it's hard to print this out. Deck of cards. Cards, images. There we go. All right, there's my deck of cards. So we talked about before with these suits and stuff. So if I wanted to calculate, I don't know, what's one of the hardest things to get in poker for the poker people? What's what? Pocket aces. I don't even know what that means. Well, that's what I was thinking of. But what are pocket aces, Chad? You got what? Yeah. Yeah. I don't think that's not too hard, is it?
Yeah.
Is it? Maybe I'll have to calculate the probability and see. So let's. I just want to calculate the probability right now of getting a royal flush. Royal flush. So we got to explain what a royal flush is for everybody who doesn't know. What is a royal flush? I don't know. I'm just asking you. So does everybody know? No? We don't have anybody that knows?
It's all the way
It's in with all the faces.
All the faces.
Starting from
What?
10.
10? Yeah.
King,
But I think
queen,
it's a particular face, isn't it?
same.
Alright, the same suit, yeah, so it's the same suit, they all have to be the same suit, starting from 10, Jack, Queen, King, Ace, all the way down, you get all 5 of those in the same suit, and you got a royal flush. So let's calculate that probability. So if I want to calculate that, so this would be probability of getting ace. Alright, what's the probability of getting an ace? What's the probability of getting a king, and so forth and so on. So it's and statements. I need all of these to happen. It doesn't matter what order it happens in, it just needs to happen for me. So hopefully you can see the and statement. It's a little tough to write that and statement. So I'm just going to write royal flush up there. So let's just say I'm going to get the ace first. So, and actually, no, I don't want to say that because that limits my probability. I want something to happen here. I want either a 10, a jack, a queen, a king, or an ace to occur. So if we want a king, that's fine. But I want any one of those to happen for me. So I guess the question is, how many cards do I have that are 10, jack, queen, king, or ace? So 20, nice. Do you see the 20 there, right? So I got 5 cards I was talking about, but then I got 4 suits. Doesn't matter which suit at first I got, but I got 20 cards that are listed there. So I got 20 out of how many?
52.
So you got 20 out of 52 cards to choose from. If I get anything else that's not one of these 20, not one of these aces, 10s, kings, jacks, kings, queens kind of things, if I don't get any one of those, then I'm done already, right? So 138% chance to get one of those. Here's the rub though, okay? So now that I pulled one of those out, I now have how many cards? 19. So I have 19 of those, but how many cards in general do I have? 32. So 51. Sorry. I wasn't asking that right. So I have 51 cards left, right? So this is any ace, king, queen, jack, or 10, right? So we have 20 of them out of 52. Once I get that card though, that sticks me in my suit, right? So let's say I get the ace of hearts here. Let's just make it easy. Let's say I get the ace of hearts. I'm stuck in that suit for a royal flush now. I have to get hearts from here on out.
So that
if I don't
wipes
get
out
hearts, then I'm done.
19,
So yeah, so not 19 though out of 51.
No.
How many hearts do I have? How
Four
many?
total.
So I got this one.
5. You need 4.
All I can get now are these
4.
left. Yeah, all I have is 4. So I was given the 8 of hearts happened, and the next step is that I have 4 out of 51 to get that next card. Because now we have hearts, right? So now I'm stuck either getting the king of hearts, queen of hearts. Right? I have to get one of these, jack of hearts or 10 of hearts. That has to happen. The ace of hearts already. So I got 4 out of them. So right, and we'll just hold off on the multiplication right till the end. We'll do it all at once. So my next one now. I need 4 cards. There's 1 card, 2 cards. I need another card. So what do I need to get? Let's say the king happened. Just make it simple. King of hearts happened. So I need one of these 3. 3 over 50. All right. If the queen of hearts happened here, queen of hearts, then I have 2 out of 49. And that's 1, 2, 3, 4. I just need 1 more. Sorry. 1 out of 48. I'm not a poker person. I'm horrible at bluffing. So I look at my cards and go, yeah! It just never works for me. I don't know why. But but I like playing cards. My dad used to love watching poker too. He loved it. I would go visit him and he had poker on. It was the most boring thing I ever watched. But I would just love watching the numbers. I don't, if you've ever watched poker, they have the probabilities right by each person, like the probability of winning. It's really interesting to see those probabilities, especially when they bluff the person out of it. There's somebody who's winning and they bluff them out of it. It's really interesting how it works. So anyway, so where do they get these probabilities? They think about these things and how many cards have already passed, how many cards have already been given, they can calculate the probabilities. So this number, I have no clue what it is, but we can calculate it in our calculators, right? So easy way to would be to use GeoGebra and write it just as is. It should give you a decimal. Right? Really small probability though.
So
whatever it's going to be.
you plug all those in as a set.
Yeah, I would plug it into GeoGebra as this with the right multiplication between each fraction. So, let me show you. Why not?
That'd be great.
We're about to get a couple more videos for the next chapter for GeoGebra. I did post one right online for the standard deviation. Start graphing here. Though I never really graph. Oof, what's new? Excellent, thank you. So first number was 20 out of 52. So notice my cursor is in the bottom, so I'm going to press the arrow button to scooch over. And I'm going to multiply, which is kind of the, what do they call it, the asterisk button on your computer. Or you can just use this button down here on your phone. So then I had 4 out of 51, right? And let's scoot over, asterisk, 3 out of 50. Over, asterisk, whoops, not plus. 2 out of 49. Multiply by 1 out of 48. And it's giving me this number. If I hit enter, it gives me a little squiggly thing. But you can already see how small this number is just by the fraction, right? 1 out of, what's that, 649,700, and really small possibility for this. It's like winning the lottery. Right? That is a very, very small percent chance of getting that.
So the homework says round to the 4 decimal places.
You're done.
Zero.
It's 0, yeah,
Wow.
yeah, it's basically 0. If you're rounded, hopefully it doesn't truncate the decimal. If you're talking about a really small probability, it should bring it off, right? Maybe it might give you a percentage, then you would move this decimal over a couple places, right? And you would have like 0.2 or 0.002 or something 0002. Something like that. All right, so that is one probability idea of this multiplication rule. We're going to get more into those in a second in that added section. Another possibility is that we can work this problem